Alright, so we got an RLC circuit and we're given the RMS voltage and the RMS current. Let's start by using that to find the impedance. Okay, the impedance is the RMS voltage, which is given to be 85 volts, divided by the RMS current, which is 0.64 amps, so I get 132.8 ohms. Now, in this case, the impedance squared is equal to R squared plus X sub C squared, because there's no inductor in the circuit. So if we plug in 132.8 here, we plug in 85 here, and we solve, we get X sub C is equal to 116 ohms. That's equal to 1 over 2 pi FC. So C is 1 over 2 pi times the frequency, which is 60 hertz, times 116. So that works out to be 23 microfarads, or 2.3 times 10 to the minus 5, if you're working in scientific notation. Okay, part B, the maximum value of the voltage drop across the resistor, where we just need the max current. That's the square root of 2 times the RMS current, so that's 0.905 amps. And so the maximum voltage drops across the resistor is equal to the maximum current multiplied by the resistance. Easy enough. We know the max current now, and the resistance is 65 ohms, so that's 59 volts. For part C, we need the max value of the voltage drop across the capacitor, and that's just the max current times the capacitive reactance. So we got that up here as 116. So that's 105 volts. Now for part D, we're saying the current is maximized. Alright, so if the current is maximized, that means the voltage drop across the resistor is maximized because those are in phase. Also, it means that the capacitor is uncharged. Right? Because if the current is maximized, that means the capacitor is not interfering with anything. And so the current at that moment is the maximum EMF divided by the resistance. So the voltage drop across the resistor is equal to its maximum possible value, 59 volts. Right? Because these are in phase. And if the capacitor is uncharged, that means the voltage drop across the capacitor is 0. And then to determine the voltage drop across the power source, we use the loop rule. So at that moment, the voltage drop across the power source is equal to the sum of the voltage drop across the resistor and the voltage drop across the capacitor, so that's just 59 volts. Right, now remember with the loop rule, that works for this given instant. It doesn't work here, right? You can't add these two up because those maxima occur at different times. So the loop rule only occurs in a given instant, like when the current is maximized or when the current is 0 or whatever. So in this case, we use the loop rule. We use the voltage drop across the resistor at that moment and the voltage drop across the capacitor at that moment, and we get 59 volts.